Experiment is to calculate moment of inertia of a flywheel. But before we deep dive into the topic, don't forget to like or subscribe my channel Physics Encyclopedia and press the bell icon. Today's our experiment's object is to determine moment of inertia of a flywheel about its own axis of rotation. For this purpose, apparatus that will be required are flywheel, digital stop clock, vernier caliper, slotted weights with hanger which are known as peg. But before starting this topic, we all have to know that what is a moment of inertia. Moment of inertia is defined as the property of the body due to which it resists angular acceleration. Here, moment of inertia I is equals to mr square, where m is representing the mass of each particle in the body and r is equal to the distance from the axis of rotation. Now we have to know that what is a flywheel. Flywheel is a comparatively big sized wheel with its mass concentrated mostly at the rim. We have to set up flywheel in such a manner that it will have less amount of friction. So when we perform that experiment, so flywheel can easily rotate. That's why we have to set a flywheel in a fixed frame or at the wall. So wheel can easily rotate. We have to use a string whose one end will be connected to flywheel and another end will be connected to peg. Here, peg is only having potential energy. When the wheel is released, this potential energy will be converted into kinetic energy of falling weight, kinetic energy of flywheel, and other will be used in overcoming the friction at the axle. Here, for reading, we have to first note that string is wrapped around the axle. We have to note that turn. How much turn does it used to wrap around the axle? Here, these turns are equal to 20 turns. When we release the peg, after some time it will fall down and we have to start our digital clock. So it will start noting the time. When the wheel will come at rest, we have to stop the stop clock. This time will be noted by us. This time will be used in our further calculation. And the turn at which wheel stop, we have to note those turn and subtract those 20 turns which are wrapped by the string. Those 20 turns will be subtracted. Now we will get another reading which is represented by n. For calculation, here formula is mentioned. mgh is equals to half I omega square plus n1 upon n dot half I omega square plus half mv square, where n1 is equals to number of rotation of a string wrapped around the axle and n is the number of rotation when peg fell down and I is moment of inertia. So we will calculate I by 2 mgh upon 4 pi n upon t का whole square into 1 plus n1 upon n minus mr square upon 1 plus n1 upon n, where r is equals to radius of axle which is equals to 1.125 centimeter and h is equals to 165.4 centimeter and weight of the peg is 500 gram. Here different reading is taken by wrapping the string around the axle and we will get different times. So we have to take average of all this to calculate the moment of inertia. So this is all about this experiment. That experiment's PDF link with the video of vernier caliper in the description. Thanks for watching.